Hello. Today we're going to talk about motion. Let's start though with position. So to define the position of an object, we need three things. We need a reference point to measure the distance from. We call this an origin. We need the distance that our object of interest is from the reference point, and we need to know on which side of the origin the object is. So in this image below, one second. There we go. Or the origin is set as this post office here. And oftentimes in problems you can set the origin yourself, although sometimes there's like a clear thing to set as the origin. And then the position we're trying to define is of this car, and apparently you're in the car. And the car is to the right of the post office. So, okay, we have our reference point and we have which side of the origin the object is on. The only thing we're missing is the distance, but it is on here for us. So 4 miles from the post office. So your position is 4 miles from the post office. Um, and also how we do this, sorry, your position was 4 miles to the right of the post office. We also need to, I'm like sometimes things will be to the left of our origin. And so in general, how we're going to do things is we're going to label things to the right as positive and to the left as negative. So this cow's position is -5 miles from our origin, while the car is +4 miles from the origin. Um, Also for horizontal motion, we'll use X as our variable label uh, for the motion. So here we have this runner and her position in X, or X equals 20 meters. That's what her position is. And that's what this M is here, meters. It's just telling us what units we're using, just like miles on the previous slide. Um, For vertical motion, we're going to use Y. So X will be horizontal and vertical will be Y. And a really common thing to do with vertical motion is to set the ground as 0. So that's what we have here. And our rock is right around 2 feet, because remember, the units are labeled here, so it says feet. You can also have a motion that's tilted, and you can still use X as the position variable. So here we have a skier, um, and they are 10 meters from the origin. And all of these, each of them, the examples had their own origins labeled or chosen. So those were all position related, but now we want to talk about speed. So speed is equal to the distance something travels divided by the time it takes to travel that distance. So remember how we're thinking about equations. We want to think about them as explaining the relationship between these variables. So for example, the longer it takes to cover the distance, the slower the speed is. And you can always check that if you have a hard time with fractions, it's totally fine to just plug it into a calculator really quick and just type in some numbers. So you could say 1 divided by 2, 1 divided by 20, compare. And you can see that the bigger the number is on the bottom of the fraction, the smaller the overall result is. So the more time it takes you to travel any given distance, the slower you're going. But the faster you travel any given distance, so the smaller the time is, the faster you're also traveling. In general, in physics, speed is going to be in meters divided by seconds because distance is usually going to be in meters and time's usually going to be in seconds. This isn't universal necessarily, although it's just like the default and preferred for physics. So units of speed are meters divided by seconds. We usually write that like this, m divided by s. So there's a couple different kinds of speed. There's instantaneous speed, so that's the speed at any given instant of time. And then there's average speed. And that one's going to be the distance traveled divided by the time of travel. So generally, most likely we're going to be finding average speed because we'll look at the total distance we traveled and divide it by however long it took us to travel that distance or, whatever's traveling. Velocity is related to speed, as in speed is part of what defines velocity, but speed was just a number. It was just saying we're moving in this fast. But velocity requires us to also know the direction that we're moving in. So it would be, for example, 10 meters per second to the right or to the left. So velocity depends on both speed and direction, and speed doesn't really care about direction. Oops, I think this is a repeat slide. Apologies. So yeah, velocity is the speed and direction of the motion. And constant velocity is what happens when speed and direction of motion are unchanging. So if either one of those changes, if either the speed or direction changes, then the velocity is not constant. It's changing. With speed, the only time the speed is not constant is if it's literally changing. So the speed's an easier one to notice because you can be like, okay, the speed is changing. So it's clearly not constant. But the velocity, the speed can stay the same, but if it changes direction, then the velocity is not constant. Now we have acceleration. So as I said, since velocity depends on speed and direction, acceleration can happen with either the speed changing or the direction changing. So acceleration is what happens when the velocity is not constant. If the velocity is constant, there's no acceleration. And we know this because of this relationship here, because the acceleration depends on the change of velocity divided by the time interval. So if our velocity doesn't change, that would be saying, okay, we have, like we're going at 5 meters per second at the beginning of our time interval and at the end. So if we subtract 5 meters per second from 5 meters per second, we get 0. That gives us 0 acceleration. So for an example where the speed might not change, but the velocity would, because the direction is changing, is driving around in a circle at a constant speed. So the speed, obviously, I just said, is constant. That's unchanging. But when you're moving in a circle, you're constantly changing the direction. So even though the speed isn't changing in that case, because the direction is, then the velocity also is. So that was just a brief introduction to kind of position, velocity, and acceleration. Yeah, see you in the next lecture.